Hello, this experiment is about acids. Some acids are so powerful they can dissolve clothing and even our skin. There are acids everywhere. There are acids in the air we breathe. Some of these cause global warming, others acid rain, and some just create a bad smell. There are acids in the food we eat and drink. They surprise our senses with a sour or tart taste. Now, today we will be analyzing two well-known acids. We will analyze vinegar to determine its acetic acid content and vitamin C for its ascorbic acid content. The laboratory work today is a quantitative analysis. That is, we are going to find out exactly how much acid is present in each of the unknowns which we will measure. Now, the chemistry of this is very simple in a sense. Essentially, you have an acid which we represent here as a hydrogen ion reacting with a base which we represent here as a hydroxide ion. This reaction then produces water. Now, the base which we're going to use is an approximately 0.2 molar sodium hydroxide solution, and you will be using that single base throughout this whole experiment. Now, the acids you will be titrating, there are four of them. The first, potassium hydrogen phthalate, which we abbreviate here as KHP. This material is a standard, so you will weigh an exact amount of this material and find out how much it takes of the sodium hydroxide solution that you have to exactly neutralize it. That will tell you the exact concentration then of the sodium hydroxide. After you have standardized your sodium hydroxide so you know its exact concentration, then you can use that sodium hydroxide to titrate and find out how much acetic acid there is in a vinegar unknown and also how much vitamin C there is in an ascorbic acid unknown. Finally, there is phenolphthalein here. This is also an acid, and you will use it in every one of the titrations. The reason for that is phenolphthalein is a very weak acid. That is, these acids will react with the sodium hydroxide before the phenolphthalein material reacts. Now, when all of either the KHP or acetic acid or ascorbic acid or whatever acid is used up, then the next drop of sodium hydroxide will neutralize the 1 or 2 drops of phenolphthalein solution that you put in. The importance of that is that while the acidic form of phenolphthalein is colorless, the salt of phenolphthalein is red, so that you know when all of either of these acids is used up by the fact that the phenolphthalein suddenly turns red when you add another drop of the sodium hydroxide. It's called an indicator. It indicates that neutralization is complete. Well, here's a schematic of what you'll be doing today, an analysis. You probably, first of all, will weigh out your standard, that is the potassium hydrogen phthalate, and dissolve it and titrate it with your sodium hydroxide. The amount of sodium hydroxide needed to neutralize the KHP will tell you the molarity of the sodium hydroxide. Then you will measure out one of your unknowns. The vinegar you will measure out with a pipette. The vitamin C tablet you'll weigh on a balance. And then you will titrate it with this sodium hydroxide to find out how much sodium hydroxide is needed to neutralize the acids in the unknown. Finally, using the molarity of the sodium hydroxide and the amount used here, you will be able to determine the amount of acid in your unknown. We'll start by weighing and titrating the standard. That's the KHP, and to do that we'll use an electronic analytical balance. This is an ideal balance to use because the weighing error with proper technique should be less than 0.1%. Now make sure that the balance is level. Make sure that it reads 0 with all the doors closed here. and then you can weigh the empty flask. Now, we'll be using a rather conservative method for weighing out the KHP here. We will first of all start out by weighing the empty flask. All right, it's 104.4827 grams. And now what we'll do is we will take this flask and we will take it off the balance and add an approximate amount of KHP to this. We'll weigh it again, and there is our weighing here. The difference between this and the first weight is the weight of KHP in our flask.
Now you're ready to start your titration. To do this, you start out with your clean burette, and you must rinse it out with the solution that you're going to use. So make sure it's closed, and then take your solution and put about 3 cc's or 4 cc's of solution in there. Roll it around so that you wash every bit of the inside of the burette, and then you drain that out into the sink, or I'm draining it out into the slop bucket here. And when you've done that once, do it a couple of times, and then what you'll do is you'll clamp your burette into place here. All right, now burette is now clamped in place. I used a little piece of paper towel here so that it was held tightly here. Now what we'll do is we'll fill up the burette with our sodium hydroxide. Make sure it's shut off, and put in the sodium hydroxide. Just fill it up. Now the 0 mark is on top here, and we will fill it past the 0 mark, way up there. And then we'll do 2 things. We'll make sure that the tip is properly filled, and then we'll lower the mark to 0. Now, to make sure the tip is properly filled, we'll turn this on and off a couple of times very fast, so that there's still some bubbles there. Now we're getting them out. There we go. So it's all surged out. And then we'll lower it to the 0 mark here. Looks like we're going to have to fill it just a little bit to get it to the 0 mark. It's always a good idea to fill it just past the 0 mark and then lower it right down to the 0 mark. Now we have a properly filled burette. Let's look at that in close-up to see what we were doing. All right, here's the tip. Now what you do is just turn this on and off a couple of times. You can see as we're turning it on and off, there are little bubbles coming down, and now that the bubbles are gone, we're all set. We'll touch the tip of this burette here to the slop bucket or some other place to get that drop that's hanging off the tip. And now we'll read the 0 mark on the burette.
The bottom of the meniscus, you see, is affected by the background color here. The other thing you should note is that there is no parallax error, because the major lines like the 0 and the 1 line here are circles, and you can only see them here as straight lines, which means that you're looking at them with no parallax error. Well, when the KHP is dissolved and ready to titrate, make sure that all of the KHP has been put into solution. Add some of the phenolphthalein indicator. I just added 3 drops, and then you're all set to titrate. The burette here is filled and set to 0.00, so we'll now start to titrate. You've got to mix thoroughly as you add the sodium hydroxide to the acid, the KHP here, and you wait until you start getting a lot of pink. And then you can start slowing this down, drop-wise here, 1 drop, 2 drops. Keep mixing, keep letting it add, mixing. Each drop then will make a pink color here, and then 1 drop makes it a permanent pink. And at this point then you will read the burette. Here's the final reading on the burette, and as you can read, it reads down, remember, 14, 14.5, 6, 7, 14.80, and as you notice, the meniscus will change a little bit as the background color changes here.
Now that we standardize our sodium hydroxide with the KHP, we turn our attention to analyzing the vinegar solution. Unlike the KHP, the vinegar is a liquid. It's actually a solution here. And so what we will do to measure out the exact volume of this liquid is to use a pipette. We'll use this 5 milliliter pipette. In using the pipette, the most important thing is the rubber bulb here. And what we'll do then is we will rinse out the pipette to start out with, just as we rinsed out the burette. To do that, squeeze the rubber bulb, slip it just over the top of the pipette. So it just is there and you can quickly take it off. Squeeze it, put it on, and now dip the tip of the pipette well below the liquid level. Take up a few milliliters of solution, and just as you did with the burette, rinse it out. We can use the rubber bulb to blow out at this point because we're not interested in exact volumes, we're just rinsing. Once it is rinsed out, then again, we will fill up the pipette. Now, to fill up the pipette, squeeze the bulb, just slip it on, and draw up the liquid. Here's the liquid level coming up here. This is the 5 milliliter mark, and now it's past that mark, bring it, but do not let it go into the rubber bulb. Whatever you do, do not let the liquid level go into the rubber bulb. All right. Once you have the liquid level, oops, it's way up here, past this mark, then just take and hold it in place with your thumb here. Slowly release the pressure on your thumb and let the liquid level drain down to exactly the 5 milliliter mark. Then with your thumb, stop it. Touch the pipette to the side so that there is no drip hanging on it, and then drain it into the flask that you're going to use for titration. Now, when you were using the flask to put in your solid and you were using the balance, that flask had to be dry. However, this flask, since you're not using it for weighing, can be wet. It can be rinsed out with distilled water. It does not have to be dried. Once this pipette now has drained completely, there's a drop hanging from the tip there. Touch it to the side. Whatever comes out, comes out. Do not use the rubber bulb when you're draining out the pipette. The rubber bulb is only used to draw up the liquid or if you're just fooling around. But when you're actually draining out the material here, it should be by gravity. All right, that's the pipette. Let's look at that in close-up. When the level of the liquid is above the 5 milliliter mark and your thumb is on top, you slowly release the pressure of your thumb and the liquid will start to drain out. Now you just keep it going, a little bit of patience until the bottom of the meniscus just hits the 5 milliliter mark. Then you put pressure on and now you have your 5 milliliters. Here's a close-up of the drainage of this pipette. Now you see, when you're through draining, what you do is just touch the pipette to the side. Whatever comes out will come out. Well, we're all set to titrate our vinegar sample. We read the initial volume of the burette, and we'll put in a couple of drops of indicator here. 1, 2, 3, and now we're all set to go. Now we can initially put in our sodium hydroxide fairly rapidly. We should keep swirling though. As you can see, there's only a small spot in the middle here. But as we keep adding at this rapid rate, that spot is getting bigger. As this pink spot keeps getting bigger. Keep swirling, we can keep adding it fairly rapid. Well, now it's getting pretty big, so I think we'll stop it. We're within a milliliter or so at the end point, and we'll now start adding dropwise. So, you see now, adding at the slower rate. Pink color isn't quite as, but now it's getting big again, so we'll go even more slowly. Just stop it and just get that going just barely. There's 1 drop, 2 drops, 3 drops, 4 drops, 5 drops. Wow, that one was just about there. Just hang the drop there, not quite a whole drop. Touch it to the side. And yes, indeed, that certainly is the end point.
Now we're pretty well finished as far as experimental techniques are concerned, but before calling it quits, just a reminder, here are the calculations that you should really understand. If you understand the experiment and these calculations, you should have no trouble. There's a few definitions here, molarity and molecular weight, and then the concept that if you have a volume and you know its concentration, you know the total amount. So this relationship is also important. Well, with that, I wish you good luck.